Hello students, welcome back. In this video we are going through Chapter 2, Section 1, Frequency Distributions for Organizing and Summarizing Data. Well, now that Chapter 1 is over, we can kind of get into a little bit more fun stuff. Chapter 1 was a lot of terms and vocabulary and just very wordy. Chapter 2, we actually begin getting into some real statistics, some numbers, some problems, some examples, etc., etc. So when we're working with large data sets, we want to have a way to take all that raw data and then organize them and summarize them in a way that we can see it a little bit more clearly rather than just looking at specific results from the observation or the study or whatever. So we are going to be using frequency distributions, and it is going to tell us about the nature of the distribution of a data set. So don't overthink this. A frequency distribution shows how data is partitioned among several categories or classes by listing the categories along with a number or frequency of data values in each of them. So let's just say that we wanted to know the ages of 25 students in a statistics class. So I would ask each of you your age, you would write it down, and then it would have 25 pieces of data. Well, that 25 pieces of data, that's fine and dandy, but it's kind of hard for me to make conclusions just looking at 25 random numbers. So now I'm going to put those numbers into a table or a chart or something that's going to help me make some conclusions about it. So maybe most of you are 18, 19, 20, maybe one 17-year-old. So I have 12 people that are going to be aged 16 through 20. I have 8 of you that are 21 to 25, 4 26 to 30, no one that's 31, 35, and then that one 40-year-old who has ambition and is going back to college. But basically, what I'm doing is I'm taking that 25 pieces of raw data and now I'm putting it in a more user-friendly category. So I have my 5 classes. Notice how these ranges are all the same distance. 16 to 20 has 5 numbers, 21 to 25 has 5 numbers. Like, none of them have only 2 numbers that would satisfy that class. The other has 10. They're all equal. And then now I can look at, majority of the class, about half of them are age 16 through 20. That's a conclusion I can make more easily now that my raw data is sorted into a frequency table. So let's look at some definitions. Class boundaries are the numbers used to separate the classes, but without the gaps created by the class limits. So the class boundaries would be 16 through 20 is a class boundary. What I mean by without the gap, well, what if maybe we're not doing something with ages, maybe we're doing your height, and then someone said that they were 5 feet through 6 feet in this range, and then this is 6 foot, to 7 foot. Well, what if you have a decimal place? Well, where that decimal place is going to go? Well, those are gaps. So 20.4 would be in no man's land. It would be within the gap. We'll get to that in a little bit, but we're going to talk right now about class boundaries, and that's just looking at the lower right here and then the upper of each class boundary. The lower class limit is next, and that will be the smallest number that can belong to each of the different classes. So the lower class limits are 16, 21, 26, 31, 36, all the lower class limits. The upper class limits, as I'm sure my little Einsteins could have guessed, it's the largest number that can belong to each of the different classes. So 20, 25, 30, 35, 40. That's the upper class limit. Class midpoint is the value in the middle of each class. So each class midpoint can be found by adding the lower class limit to the upper class limit and dividing it by 2. So what's halfway between 16 and 20? Well, 18. What's halfway between 21 and 25? Well, 23. And if maybe it's not an easy number, you can always just do it this way. So take the lower class limit, the upper class limit, add them together, divide by 2, and that'll give you the midpoint, just the average of the 2 numbers. Class width, and this is the one that so many students get wrong, so pay special attention. It is the difference between 2 consecutive lower class limits in a frequency distribution. So two consecutive lower class limits. So 16 and 21. 21 minus 16 is 5. So the class width is 5. Most people, well, I shouldn't say most, but many students are tempted to say the class width is the upper limit minus the lower. So, 20 minus 16, class width is 4. Wrong. Don't do that. You'll make me really, really sad. It is taking the consecutive lower class limits and subtracting them. You can do 25 minus 20, 40 minus 35, 31 minus 26, but you have to be consistent. And then no matter which way you do it, you'll get 5. Okay, so procedure for constructing a frequency distribution. This is very wordy, but I want to leave it in here just to have it there. But I think the example is going to do a little bit of an easier job explaining it with using fewer words. So select the number of classes you want to have. Again, this is now, we are constructing a frequency distribution given raw data. So first, we have to decide how many classes we want to have. Then we're going to determine the class width. We want to know how many data values we want to be in each of those classes. So we're going to take the maximum data value minus the minimum data value, and then divide that by the number of classes I selected in section 1. We want to get a convenient number, so it's usually best to round up. Meaning if you do this and then you get a class with a 4.5, well, that's kind of an ugly number. So round it up to 5, for example. Next, you choose the value for the lower limit, which is either going to be the minimum value or a convenient value slightly below the minimum. Again, maybe if the lowest minimum value was 18, but you say, okay, it'll be a little easier for me to have it start at 15, just to kind of keep it consistent, and it's more convenient to work with multiples of 5. So using the first lower limit and class width, now we can create our chart. Then we're going to fill in the chart, and then take each individual data value and put a little tally mark in the appropriate class. When you're done, add the tally marks to get the frequency. All that is very wordy. I want to just go through an example. I think that'll do a better job. So using the McDonald's lunch service times in the first table, follow the procedure shown in the next slide to construct a frequency distribution shown in the second table. So this is the raw data, and this is our finished product, just to kind of show you what we're trying to accomplish. So we're going to take this, and we're going to make this from it. You might have done this in high school. I know in the high school I teach that I've done this with my algebra kids, but we'll go through it again, assuming it's the first time you've seen it. So we're going to select 5 as the number of desired classes, and that's arbitrary. 5 seems pretty good. Again, I don't know this, what it will look like in the end. I'm getting to here, but we're choosing 5. So we then have to find out our class width. So what's our minimum? Well, fortunately, they're already sorted, so minimum is going to be 107. Oh, actually, that's not true. The minimum is going to be, look through it, is it the 90? Maybe 83. 83 will be the minimum. And then the maximum will be, I guess, the 308. Yeah. So we'll do our class width, it's the maximum minus the minimum divided by the number of classes. So we got 45. But we're going to round that up to 50. That just makes it a more easier number to work with. Okay. So the minimum data value is 83, so the lower limit of our first class has to be somewhere below that. If you start at 85, well then your 83 won't fit anywhere. So let's start with, say, 75. That's just a more convenient number to work with. You could do 80, you could do 60, you can do 50, but we're just going to start with 75. Nice multiples of 25. Our class width is 50, so we're going to add 50 to 75. So we get the second lower class limit of 125. Continue to add 50 until we have our 5 lower limits. So therefore we have 75, 125, 175, 225, and 275. So basically at this point we figured out these lower class limits. Right here, yeah. So then we list them vertically, and then from here we can identify the upper class limits. Just going to be, well, 1 less than 125 is 124, 174, 224, 274, all the way up to 324. Then we can enter a tally mark for each data value in the appropriate class, and then add up all those tallies to find the frequency shown in the table. So 11 of these raw data values fall between 75 and 124. Only 2 of them fall between 275 and 324. And now we took our raw data, which is very ugly representation, and we put it in a much more user-friendly format where we can actually make inferences about it. Okay, where was I? Okay. The next thing is relative frequency. Relative frequency distributions, or percent frequency distributions, is that each class frequency is replaced by a relative frequency or proportion of a percent or a percentage. So basically, the relative frequency is going to be, we take the frequency for each class and then we divide it by the sum of all frequencies. If you want it as a percentage, you just take the relative frequency in decimal form and multiply it by 100%. And this is just showing you what percentage of each class is represented. So this isn't rocket science. So each class frequency is replaced by a relative frequency or a percentage. It can be either way for a relative frequency distribution. So these two columns are what we got previously. So if you want to get the relative frequency as a decimal, we just take the 11, divide it by 50. Why 50? That's the total number of data values. And then we get 22% of all data values fall between 75 and 124. 48% of all data values fall between 125 and 174. And then we just continue that down. One thing to note is that if you add all the relative frequencies together, you should get 1 or 100%, or maybe there's a little wiggle room for rounding errors, but everything should be at that 100% if all data values are represented. Cumulative frequency distribution is that the frequency for each class is the sum of all frequencies for that class and all previous classes. So with this, well, let's look at the first one. How many data values are less than 125? Well, there's 11. All of these ones are less than 125. How many are less than 175? Well, it's going to be 11 plus 24, which gives me 35. How many cumulative frequency is less than 225? Well, it's going to be 11 plus 24 plus 10, or the 35 plus 10 for 45. Less than 275 is 45 plus 3. Less than 325 is 48 plus 2, or all 50 of them. So all 50 data points are less than 325, or 100% of them. Sometimes we might want to make comparisons, so we can combine two or more relative frequency distributions in one table to make comparisons much easier. So the table below shows the relative frequency distributions for the drive-through lunch service times for McDonald's and Dunkin' Donuts. So 0 McDonald's customers had a wait time of 25 to 74. And likewise, 0 Dunkin' Donuts people had anything above 224. So because of the dramatic differences in their menus, you might expect there to be different service times. So by comparing the frequencies, we see that there appears to be a conclusion that can be made that Dunkin' Donut times are lower than McDonald's. Okay? So critical thinking, using frequency distributions to understand data. In stats, we are often interested in determining whether or not the data has a normal distribution. And this is going to be the most important distribution that we deal with. So a normal distribution is this kind of bell-shaped curve. It starts off low, increases, gets really high, peaks right here in the middle, and then it repeats the same process down. And it's pretty much symmetric as well. All right, that concludes Chapter 2, Section 1.